So let's move on to our next lecture. The moderator of our next lecture is Dr. Nirmal Basil. She is a
Am
director
I
and
audible?
clinical embryologist and the founder of Jenny's Fertility Center, Ming State Medical Institute in Berlus. She is a member of ISAR IFS and IMA Chandigarh, Cox Chandigarh. She has more than 19 years of experience in infertility treatment, and she has presented many papers in various national and international conferences. She published papers in various journals, and she is a pioneer in surrogacy programs in Chandigarh, Punjab, and currently she is holding the office of vice chairperson in ISAR Chandigarh. So welcome, Dr. Nirmal Basil.
Thank you, Yoshita, for the kind introduction. And am I audible?
Yeah, ma'am.
Yeah. So today our topic is artificial intelligence and machine learning. So I would just like to give a small overview that what we have understood till date, that the human brain possesses the highest intelligence as it is assumed by us, Homo sapiens. But we have created artificial intelligence to be a helping tool in our day to day life in the form of Alexa, Siri, GPRS, and the list is endless. Artificial intelligence and machine learning in the embryology lab will decrease the load off the shoulders of the embryologist. And that will be highlighted by Dr. Can I have the CV, please? Yeah, I can't read it. Yeah, doctor, I can't, it's not readable at all. Dr. Carol from San Diego, as I've had the research, I've been through the research. She is a reproductive embryology, a molecular biologist and a reproductive scientist from US. Can I have it? It's not clear, sorry. Can somebody just read it out for me? Yoshita? Dr. Ved Prakash, can you read out the CV for me?
Put this on your face.
So, Dr. Carol, she is.
My meeting is about to start.
Can I read it, sir?
Yeah. Please.
Hi. You know what?
Sorry, Carol. Apologies.
Apologies.
No.
It is not visible actually.
I think I got a helping hand. Please. Yeah, I got it on the news. Thank you so much, Yasmin. So the current research interest of Carol are in the application of deep technology, longitudinal database structure, mobile technology applications, and again it is disappearing. Carol, can you please enlighten us? We don't understand artificial intelligence as yet.
Yeah, absolutely. So let me just start my presentation here. So first of all, thank you so much for having me. I have to apologize. I'm at the airport, headed out on an airplane very shortly here. So I'll just give you a very quick talk. We recently published a paper about a deep learning early warning system for embryo culture conditions and individual embryologist performance in the IVF laboratory. So
I'd like to continue morning with Group A.
What do we want to talk about today? Is there actually a problem analyzing data in the IVF lab? And our College of American Pathologists says that documenting the competency of staff is the #1 most cited deficiency by all major laboratory accreditors. They go on to further say that 1 out of 4 laboratories does not fully meet the documentation requirements. No, we're not going to miss it, honey. We're not going to miss the airplane. So sorry. It's my meeting, darling. It's my meeting. Look there. There's our line right there for the airplane. So stop. I'm so sorry. Can you still hear me?
Continue.
Yes,
Please.
yes.
Yeah, we can hear you.
Okay, so sorry about that. I have a very sleepy child here with me. So the goals of total quality management are to map all the processes, describe all the procedures, and assess how the procedures might fail. We want to consider the impact of the failure and ensure that the clinic and staff have the requisite skills and knowledge and the equipment to achieve all of these performance targets. So we also want to take corrective action and monitor the trends and be able to take this corrective action when we find non-conformance events. Now, we know that we should be monitoring many things, but what to monitor and how best to monitor them are unclear and not very well standardized. So a recent study comparing 36 labs found that many different things are being assessed, and that was using a popular IVF QC app. And we also know that cryostorage failures can happen at any time, and even to the best programs. And I think we've had a lot of talks today about how to prepare for the unexpected. Now, one of the ways that I think about contemporary quality control and assurance in the IVF lab is that it should be automated, and it should actually strive to elevate our processes beyond a cursory monthly review of the data. So I'm imagining a future where IVF lab directors have a very Google-like experience. When you log onto your Gmail, you can seamlessly transition back and forth between different apps, and you don't really you don't have the feeling like you have left the Google platform, and indeed you haven't. And in our field, we have all of these different electronic systems. They all play some small part in our quality assurance or our quality control. And I would love to see a future where these are integrated into a single dashboard for IVF lab directors. So I just wanted to talk a little bit about where AI systems can interact in the IVF lab. So electronic medical records, individual KPIs, and outcome measures, as well as QC/QA apps, virtual training programs, alarm systems, witnessing systems, and then of course, document control is needed for each one of those. So when I was thinking about giving this talk today, I was thinking about the difference between Web 1.0 and Web 2.0. What is the difference between simply digitizing the forms that you already have or the processes that you already have? Instead of just digitizing it, let's start to think about how artificial intelligence can give us more of a Web 2.0 experience. So when we're talking about mobile apps and web-based systems, they can work on any device, and they surpass very simple information portals that just passively receive information. They can provide red flags for critical alerts, for incomplete data entry, for deficiencies, errors in the data entry itself, and prediction of non-conformance events. So like I said, we want to surpass taking the exact same form that you already have and simply making it digital. We want to add specific features that require interactive participation and encourage collaboration and information sharing. So we're talking about, instead of just typing information into a form, data visualization displayed to the right people at the right time, instantly, not after the 2-week wait after the embryo transfer. And we're also talking about uploading images to the patient record versus analyzing those images and making recommendations and reducing the manual and routine rote labor that goes into every embryologist's day. Now, when the Vienna Consensus met, they gave us several nice KPIs. ICSI damage rate, I would say, is the #1 KPI that all embryologists are judged by. But further, we want to make sure that our cleavage rate and our blastocyst rate are falling within range. And what we saw from the Vienna Consensus is that they didn't recommend that blastocyst quality or usability be taken into consideration, but simply the rate of blastocyst formation. And what we have found using deep learning and neural networks is that computers are obviously, they're made to be consistent and objective, and they surpass the embryologist consistency and objectivity when grading embryos and assigning different grades. Now, I think everybody knows that embryologists pretty routinely agree on the top embryo and the bottom embryo. But there are a lot of transfers that happen in between the top embryo and the last embryo. And so how we are agreeing on the second embryo to transfer or the third embryo to transfer, and how do we decide what is the lowest quality embryo we'll biopsy? And all of those things matter to the number of blastocysts that are usable per cycle. So we also presented some data about being able to use AI systems to monitor individual embryologist performance, and as well to give us an early warning KPI that was instructive at day 3, which is much sooner than many of the other KPIs that we routinely measure in the IVF lab. So in this paper, we demonstrated for the first time the power of using AI predictions to monitor the performance of individual embryologists, their technical competency, as well as the embryo development stage markers to predict the embryo culture environment. We demonstrated the link between quality assurance, performance, and patient outcomes. So this study was the first to describe AI, how it could be used to automate the monitoring of individual embryologists performing ICSI. And ideally, the remote monitoring will be performed through a LIMS system that can augment all this data in real time, along with the embryo images, competency assessments, and many other types of patient-related clinical and laboratory KPI data. So some of the data directly from the paper is that the AI-generated KPI for predicting high-quality blastocyst formation actually had the highest association with ongoing pregnancy rates. So this was the only cleavage stage KPI that we examined, which was able to detect actual changes in our culture environment that resulted in a pregnancy rate dropping below the threshold of 50%. So we know that the use of the AI system can help us detect these fluctuations in in vitro embryo culture system and could have an impact on clinical outcome. So we also wanted to show that the AI measurement and our manual KPI measurements were very similar, and we presented those data in the paper as well, so that we can be assured that the AI systems are working as well as the manual grading systems. And so my talk today is very short, and it sounds like everybody there might be going a little bit over their time, so I'm sure that you'll appreciate the brevity of my discussion with you today. But I would like to encourage you, as we're all learning more about AI systems, to visit us at reproai.org, and it's repro-ai.org, and download our data set, some of the PDFs that come with it, and really start to kind of dig into this concept of using advanced analytic systems for the IVF lab. So that's my last slide. Thank you so much. Thank you for putting up with the airport.
Thank you, Carol. It was very interesting topic, but we have to learn a lot yet.
Yes, yes.
Yes,
There's
we
a
are
long
still,
way to go. So I
yes.
think in this paper, I think the biggest win for me for this paper was that we demonstrated that it could be done, proof of concept, but there's a long way to go to implementing it routinely in an IVF lab.
Thank you so much. Thank you. It was really a very good introduction for us. And we are hoping to have a good future with artificial intelligence and machine.
Yes.
Thank you.
So thank you so much.
Thank you, Dr. Carol. Thank you so much.